So then now I think you have understood the how to download the software. Have you understood how to download the software,
Yes.
all of you? Okay,
Yes, sir.
so you
Yes,
can
sir.
download the various software, not only the COMSOL, you can download ANSYS also. For example, if you will click on if you put in search ANSYS, so you will get ANSYS also. Various versions of ANSYS also you will get from these websites. Okay, you can get CATIA also, SolidWorks also you can get antiviruses also. Okay, so these websites, but you are getting the only crack version, not license version. Okay, now next to that, here you can see this COMSOL Multiphysics software is used for here. If you want to download the any physics tutorial, so you can download it from search. So here if, for example, if you want to download the some of the tutorial related with the corrosion, so you can put it into the corrosion and then you will get the various tutorials. So from that tutorials also you can learn how to solve the problem. Okay, how to solve the problem. So we'll see later the how to download this tutorial and how to use that. For example, I will click on the stress corrosion and here you will get direct module of this problem. So download the application. Here you will get the PDF, you will get the various text data. For example, if you want to give input to your problem, that also you can give from here the stress corrosion parameters, for example here. So that also you can give directly to your problem. So how to give it, that also we will see in today's lecture. Okay, so now next to that we'll start to see the application of that COMSOL Multiphysics software. So objective of that today's lecture is the learner will able to understand how to use the COMSOL Multiphysics software in heat and mass transfer applications. Okay, so now I think you have learned the various problems related with the conduction, convection and radiation related, or the various problem you have solved in your class also. For example, if I think all of you have learned that heat and mass transfer subject. So in heat and mass transfer subject, for example, if you have used you have solved the some conduction related problem, that also you can simulate by using that COMSOL Multiphysics software. For example, here you can see this is the first problem we will solve, steady state 2D heat transfer with the conduction. Okay, so for that purpose, what you have to do, you have to open the COMSOL Multiphysics software. So already I have downloaded that COMSOL Multiphysics software. So it will take some time to open. That is depends on the your RAM of PC. Okay, before this we will see the numerical which we are going to solve. So this is what this example considered 0.6 meter by 1 meter domain for the boundary condition. Left boundary is the insulated. For example, if you will see, this is the this is the what 0.6 meter is the width and 1 meter is the height of that rectangular body, and left side is insulated. For example, this side will be the insulated. Insulated means what? Heat is not flowing from this section, and the lower boundary is kept at 100 degrees centigrade. Means at bottom 100 degrees centigrade heat is flowing from here, and that will be the moving towards the outside, because moving towards the two remaining boundaries. For example, this boundary is what? This boundary is insulated. So यहाँ से heat pass होगा क्या? नहीं. So no heat will be passed from here, but heat will be passed from that 100 degree centigrade to remaining portion. And at upper and right hand boundary, you will get what? That is, there is the what? Convention is occurring here, because these two edges are exposed to where? these two edges are exposed to environment, and here what will happen, the heat transfer coefficient H will be the how much, 750 degree centigrade, and temperature will be the what, atmospheric temperature is the
Hello,
0.
sir. Hello.
Hi.
Hello.
Yes, yes.
Yes, sir. Sorry for interrupt, but can you please make it slideshow on?
Slideshow.
Yes.
Okay.
Yes, sir.
Okay.
Yes. Now it is visible. Yes. Yes. Okay. Thank you.
Okay, so here you can see, so already this problem I have explained. This example considers what, 0.6 mm is the width of this wall, simple wall, and the 1 meter is the height. So here you can see the left hand boundary is the insulated. So this left hand boundary is what, insulated boundary, and the remaining boundary is the kept open to atmosphere. Okay, and at bottom we are giving exposure of the 100 degree centigrade, means we are providing temperature of 100 degree centigrade at bottom. So now we can see the how heat is transferring from this 100 degree centigrade to environment. Okay, so that also we can see. Now we'll see the whether this software is getting open or not. So I think this software is now open. So here you can see, after clicking on this software icon, here you will get this window. So here you can see this file tab will get open, and here you can click on new. If you will click on new, here same window will get open, and here the model wizard and the blank model, these two tabs will you are getting. So if you will click on the blank model, it will open only the 3D geometric modeling. Okay, but if you will click on the model wizard, what will happen, these 6 tabs will be get open. So actually BE people may know the types of elements which are used in finite element analysis. So can anyone tell me the types of elements which are used in finite element analysis? Can anyone? BE people, whether BE peoples are
1D
here?
element, 2D element,
1D element,
3D element.
3D element, 2D element, 2D axis symmetric, then 1D axis symmetric, 0D. These are what? These are the finite element analysis elements. Okay, FEA elements are there. So why these 6 elements we need to use? For example, if you are using the 0D problem, when we have to use 0D problem, so if our heat is flowing from this point to atmosphere, for example, in some electromagnetic equations or some electromagnetic applications, the point from the points, what will happen, the electromagnetic flux is flowing from point to surrounding. Okay, likewise in heat transfer also, what will happen, heat is flowing from the point to atmosphere. Okay, in such problem you can use the 0D elements. If your problem is simple, and that problem has or application has the single degree of freedom only in x direction, then at that time you can use the 1D. Okay, so 1D axis symmetric, if you are the meaning of that axis symmetric means the problem or this application is symmetric about the axis. For example, if you want to draw the cylinder, okay, so in finite element analysis, there is the method of 1D axis symmetric and 2D axis symmetric. By using that, you can draw only the single plane, and you can convert that single plane into the 3D axis symmetric. Okay, 2D axis symmetric, and at last you can see that element in 3D also. Okay, so we will see the problem on 2D axis symmetric also. Okay, and last one is the 3D. All people will, or the most of applications problems are solved by using the 3D element. Okay, and now some people will ask when we have to use, when we have to use these elements. Okay, so if you want to solve problem as early as possible, so which element you will use? Can anyone? So if you want to solve your problem fast, then you have to use what 0D or 1D problem, because this is the very simple elements. This is the very simple elements, and by using that elements we can solve the problem within fraction of second. Within fraction of second we can solve the 1D and 0D problem. But if you are moving for visuality purpose or for more visualization purpose, we need to move from 1D to 2D, or 2D to 2D axis symmetric, और 2D axis symmetric to 3D axis symmetric. इससे क्या हो जाएगा, हमारा विजुअलाइजेशन भी बेटर हो जाएगा. बट जैसे हमारा विजुअलाइजेशन बेटर होगा, time required for solving this problem will be, for our competition time of this problem will increase. मतलब टाइम प्रॉब्लम सॉल्व करने के लिए हमें टाइम ज़्यादा लगेगा फ्रॉम 0D to 3D. बट होगा क्या कि आवर सिमुलेशन विल बी गेट क्लियर. मतलब सिमुलेशन जो आप कर रहे हो उसका विजुअलाइजेशन आपको ज़्यादा क्लियर होगा. ओके और कम से कम टाइम में सॉल्व करना है तो यू कैन यूज द 2D or 1D problem also. Okay, so now have you understood when we have to use these elements? Okay, so now here we can see, we'll try to model this problem, steady state 2D heat transfer with the conduction. Okay, now for that purpose here you can see they have given only the 2 dimensions. Okay, so I will use what for 2 dimension, which element we will use for 2 dimension? We will use the 2D, 2 dimension. Okay, so now I will click on 2D. After clicking on the 2D, here you can see the various physics you can see. The name of this software is what? COMSOL Multiphysics. So by using that COMSOL Multiphysics you can solve the multiple physics problem. मतलब जो भी physics अब तक found हुए उतने physics इस problem में include किए हैं. For example AC/DC problems. AC/DC means for example electrical problems can be solved by using this software. Electrical field, magnetic fields. Okay, after that here you can see the acoustic related problems, for example manufacturing of sound, or for example if you want to fix the home theater in your home, so that analysis also done by using the acoustic. Or for example in theaters, if you want to check the acoustic effects or sound effects, that also studied by using this acoustic physics. After that chemical species transport, so chemical peoples can use this module of chemical species transport. Next, electrochemistry. So this electrochemistry module is used by what? Mechanical people also. Okay, because in battery analysis also you can do by using this software. So lithium ion battery or lithium ion battery deform geometry. Okay, so all these analysis related with the batteries or corrosion related analysis also we can do by using what? Electrochemistry. After that, next to that, here you can see the fluid flow. So computational fluid dynamics. Have you heard the word computational fluid dynamics? CFD, आपने CFD सुना है क्या? I'm audible?
Yes, sir.
Okay. So these CFD problems also solved by using this software. So CFD के लिए आप ANSYS भी use कर सकते हो. You can use the COMSOL Multiphysics. But when we have to use these COMSOL Multiphysics, actually the all problems from the small application to large application can be solved by COMSOL Multiphysics, and the accuracy of that COMSOL Multiphysics is more as compared to ANSYS. But publicity or the familiarity of this COMSOL Multiphysics software is less in industry field but more in research field. So that software is used in mostly in research field. Nowadays, if you will see, this COMSOL Multiphysics software is used mostly in research field. Okay, after that here you can see this is fluid flow. Is what? Fluid flow. Here inside that fluid flow you can see the various types of fluid flow. Single phase flow, for example, if inside the pipe the water is flowing, that will be the what? Single phase flow. For example, air is flowing through pipe, that is also a single phase flow. मल्टीफ्लेज फ्लो में क्या होगा, यहाँ पर देखेंगे तो मल्टीपल flow of the fluid will be there. For example, if water is mixing inside the oil, that is also a what multiple flow. Then porous media, subsurface flow, non-isothermal flow, that also I think you have seen non-isothermal flow, which is the flowing through pipe. So such examples also you can see in fluid mechanics as well as in thermal. Okay, so various problems related with the fluid flow, it can be solved by this software. Next to that, this heat transfer model. So today we are concentrating on this heat transfer model and the heat transfer in solids. Okay, next to that, here you can see these are the various models. So mechanical peoples can use that structural mechanics. Okay, so inside that structural mechanics we can solve the solid mechanics problem, plate related or the beam related problem, stress problem, multi-body dynamics problems can be solved by mechanical people by using that structural mechanics module. Okay, so now we will see the one module, that is the what, heat transfer module. Now you have to select what, यहाँ तक समझ में आया, how many physics are included inside that COMSOL multiphysics? Are you getting?
Yes, sir.
Okay, so here you can see today we will see the heat transfer module and we will click. Actually the problem which I have taken here, that is what, steady state 2D heat transfer with the conduction. So first what I have done, I have taken the 0.6 meter is the width of that wall and the 1 meter is the height of that wall. So due to that reason, this is the 2D related problem. Due to that reason, I have selected the element which is what, 2D element, and then I will select the type of physics. Physics का type कौन सा है? Heat transfer. Heat transfer in solid. Then I have to click on the add. So it will add the heat transfer in solid. So it will. So here you can see the whatever information related with the heat transfer in solid, heat transfer. So here in that heat transfer module, you can see the which is the dependent variable, that is the temperature. Actually this dependent variable is nothing but what, degree of freedom in case of the heat transfer problem is what, temperature. So degree of freedom in case of the mechanical problem is what, the movement of the component in x direction, y direction or z direction. So that will be the what, a degree of freedom. Okay, so here in a heat transfer problem also there is degree of freedom, that is what, temperature is the degree of freedom, or you can say dependent variable. So here I have selected what, heat transfer in solid, then I will select the study. So it will ask us, okay, which types of study you want to use, stationary study, time dependent, or thermal with the eigen frequency, thermal with the frequency domain, or the more studies also you can add. Okay, so now mostly we will see the two studies. So this is the stationary study or the time dependent study. Okay, so for example, if your heat is moving from one side to another side, okay, and if continuously heat is moving from one end to another end with respect to time, at that time you need to use what, time dependent. मतलब with respect to time यदि आपको study करना है तो you have to use what, time dependent. And if you are doing, if your heat is not flowing with respect to time, at that time you can use what, you can use the stationary. यहाँ पर देखेंगे, if you will click on the stationary, it will give information related with stationary study. The stationary study is used when field variable do not change the over of time. मतलब टाइम आपका जो टेम्परेचर है, the temperature is not varying with respect to time. For example, अभी 100 डिग्री सेंटीग्रेड टेम्परेचर दे रहे हो, whether that temperature is increasing with respect to time. If not increasing, that study you have to do with the stationary. If that temperature is changing with respect to time, at that time you have to use time dependent model. For example, if you are doing the study of the furnace, so furnace is continuously you are heating, and initially the temperature of furnace is the 40 degree centigrade. After sometimes that temperature is increasing for 40 degree centigrade to 1000 degree centigrade. So यहाँ पर क्या हो रहा है कि टेम्परेचर इज इंक्रीजिंग विथ रिस्पेक्ट टू टाइम, मतलब आफ्टर 1 आवर the temperature of that furnace is increasing from 40 degree to 1000 degree centigrade. At that time you can use time dependent study. So most of these two studies are used in solving the application oriented problem. So today we will use the stationary. So now I have selected study also. So what steps I have done here? So first I have selected the element, type of element, that is the 2D. Then I have selected the physics, and then next I have added the study. Okay. So now it will take some time to open the next window. Okay, now here after that, after clicking selecting the study, you will get this window, and here you can see this is the what, this is the ribbon, and on the ribbon you can see the application builder. You can build the application. जैसे हम प्रोग्राम लिखते हैं और प्रोग्राम के पीछे मतलब इंटरफेस के पीछे प्रोग्राम रहता है और आगे क्या रहता है, एप्लीकेशन रहता है. In application, what we are doing, we are giving the value of, for example, if you are solving the problem of stress, what you are doing, you are giving the input, you are giving the input of what, फोर्स एंड एरिया. आपको डायरेक्टली स्ट्रेस मिल जाता है. तो वैसे ही यहाँ पर देखेंगे तो एप्लीकेशन भी आप बिल्ड कर सकते हो. यहाँ पर यू कैन सिलेक्ट द वेरियस एलिमेंट्स, यू कैन सिलेक्ट द 3D 2D, यहाँ से भी आप सिलेक्ट कर सकते हो. लेकिन हमने क्या किया है, अभी 2D सिलेक्ट किया है. यू कैन गिव वेरियस वेरिएबल फ्रॉम दिस टैब, डेफिनेशन टैब. ज्योमेट्री टैब से आप क्या कर सकते हो, यू कैन गिव ज्योमेट्री ऑफ, for example, if you are drawing the 2D geometry, then you will get the rectangle, square, okay, triangle like option you will get here. You are in physics, you can add the different physics for your problem. Okay, this is the mesh and this is the completion. Now next to that here, due to time being, I will complete fast. In finite element analysis, what steps are inside the finite element analysis? FEM में कौन कौन से steps रहते हैं? Can anyone? Can anyone tell me the what steps are in finite element analysis? Can anyone tell me?
Preprocessor, solver, post processor.
Okay, preprocessor,
Pre-processing.
post processor, and solver. Right. Why this pen is not working? Okay. So first is what? Preprocessor step. This is the steps. Then next is what? Post processor. And third one is the what? Solver step. So that 3 steps are covered in finite element analysis. ये सॉफ्टवेयर कौन सा है? फाइनाइट एलिमेंट एनालिसिस सॉफ्टवेयर, FEA सॉफ्टवेयर. तो यहाँ पर देखेंगे इन प्री प्रोसेसर व्हाट यू कैन डू, यू कैन जनरेट द ज्योमेट्री, यू कैन गिव द पैरामीटर्स, and in post processor what you can do, you can give material, you can give the boundary condition to your problem, and in solver what you can do, you can read the results. Okay, so these 3 steps are there in finite element analysis. So now in your case, for example, if you will see, this is what, this is the COMSOL Multiphysics, and this model wizard will give us what? Inside the model wizard you can see, here you can see these preprocessor steps. So these preprocessor steps are covered till here. So यहाँ तक क्या है कि these are what? Preprocessor steps. In preprocessor what you can do, you can give parameters, you can generate the geometry. Okay, and in post processor what you can do, you can give material as well as the boundary condition to your problem along with the meshing, and this study to results will come under what? Solver step. Okay, now next to that here you can see what we inside that model builder what we can do. तो यहाँ पर देखेंगे मॉडल बिल्डर के अंदर हम क्या कर सकते हैं, यू कैन प्रोवाइड द पैरामीटर्स टू योर मॉडल बिल्डर, मतलब जो भी आप मॉडल जनरेट कर रहे हो उसको आप पैरामीटर्स प्रोवाइड कर सकते हो। फॉर एग्जांपल जब भी आपने कुछ प्रॉब्लम सॉल्व किए होंगे, फॉर एग्जांपल इफ यू हैव डन सम प्रोग्रामिंग ऑफ सी प्लस लैंग्वेज, व्हाट यू आर डूइंग, पहले आप क्या करते हो, फर्स्ट व्हाट यू आर डूइंग, फॉर एग्जांपल आई वांट टू सॉल्व, 1 minute, I want to solve I want to do addition of a and the b, so a and b की एडिशन करनी है तो पहले आपको क्या करना पड़ेगा, you need to define the a and b, so for example a is equal to 5 and b is equal to 2, so in C you will get what, addition of a plus b, so here what you are doing, first you are defining the value of a and b, so that you can do by using the parameters के अंदर क्या कर सकते हो, you can define the वेरियस वैल्यूज, ओके, जो भी आपको पैरामीटर्स रिक्वायर्ड है, फॉर एग्जांपल हीट ट्रांसफर का प्रॉब्लम है तो आप क्या कर सकते हो, यू कैन डिफाइन द पैरामीटर्स विड्थ, तो यहाँ पर अभी डिफाइन करके आपको दिखाता हूँ, विड्थ of your problem is what, how much was the width, 0.6 for this problem, and height will be the how much, then height will be how much, 1 meter, okay, so here you can give unit also, so here I have defined the height, we will define the width in at the time of generation of geometry, okay. Next to that, in definition you can give what, you can give the variables, you can give the function, for example in some problem what will happen, if you need to give sudden impact, at that time you can give the step function, if you want to give rectangular function, that also you can give with the help of that functions, okay. Now next to that, here you can see the geometry, how to draw geometry, so we'll start to solve a problem as early as possible. First we'll see the what parts are or what steps are inside the finite element. So first is what, geometry definition, geometry definition में हम parameter define करते हैं, if you require the give some step function or various function or variable, you can give inside the definition. If you want to give geometry, you can generate the geometry by using this geometry tab. Here you can add the material, for example if you click right click on the material, here you can see this is the add material, and here from which you can add the materials in built-in tab. For example if you want to add the air, here you can see air can be added here, or the different materials, various materials are available, as per physics are also materials are available, ACDC, battery, bioheat, corrosion, MEMS related problem, piezoelectric related problem also solved by using that COMSOL multiphysics. Okay, next to that, here this is what this is the physics. Inside that physics you can give the various inputs. For example if you can give the temperature or the thermal insulation, heat flux, periodic condition also you can provide, okay. And this is the meshing. So meshing is what, meshing is the one of the step of the finite element method, and that is very important. In meshing what you are doing, you are converting the your domain or problem in small parts, so that is nothing but what, discretization. For example this is the rectangle, and solving this whole problem is difficult, so if you divide this problem in small parts, what will happen, it is easier to solve. So before this what we are doing, we are dividing this problem or domain with the help of the meshing in small part. For example बड़ा rectangle लेने से क्या है कि छोटा rectangle लेके आप उसका solution निकालो, and then you can apply the solution to whole problem. इसका एक solution निकाल के आप whole problem को apply कर सकते हो with the help of this meshing, okay. And next to that, here you can see we have already taken the stationary study, and with the help of that stationary we can solve the problem, okay. So I think you have understood the basic overview of that COMSOL multiphysics window. Anyone have query regarding this? ठीक है, किसी को कुछ प्रॉब्लम रहेगा या कुछ आपको पूछना है तो यू कैन आस्क मी. So here you can see we'll start to solve problem. So here this is the first, the steady state 2D heat transfer with the conduction. This example considers what? Here 0.6 meter is the width and 1 meter is the height. For the boundary conditions, the left side is insulated and lower boundary is kept at 100 degrees centigrade. Upper and right hand boundary is converting it 0 degrees centigrade and heat transfer coefficient of 750. And thermal conductivity of that material is what? 52. So material property उन्होंने directly दे दिया है. So here what we will do, we'll first try to draw a geometry. So I think if you use the 3D modeling software or AutoCAD भी आपने यूज किया होगा, तो you can use this software very easily. But for geometry, आगे का आपको यूज करना है, उसके लिए थोड़ा आपको efforts लेना पड़ेगा. Next, here I will select the rectangle because the geometry is rectangular geometry. Width कितना है इसका? Width of this problem is how much? Can anyone? How much is the width? How much is the width? Are you there? So width is 0.6
1 meter.
meter and the height will be the 1 meter. So I have drawn. So here you can see here the rectangle has been getting generated here. Okay, next to that, as per steps, you need to add the material. So you can add the material from here also by right clicking. You can add the aluminum, copper, wood, or different insulating materials are also there, that also you can add. But here they have given the material property of thermal conductivity. So I will add directly that thermal conductivity to material only. Okay, and here this is the heat transfer in solid. So I will provide the boundary conditions. So I will click on the solid one. So here you can see in solid one, so already it has selected this domain one, and the below domain one you can see the various material properties are there. First material property, it will says that the from material. So already whether we have selected material हमने सिलेक्ट किया है क्या यहाँ पर? So till we have not selected the material, but they have given the material property of 52. So here what we'll do, user defined thermal conductivity, user defined material conductivity is the 52, and they have not provided the density. So we'll take density 0 and CP heat capacity I will take 0. Reason behind this is for 2D component there is no volume is there, but for 3D components, whether for 3D components volume is present, 3D component का volume रहता है क्या? रहता है क्या? Whether for 3D components volume is there?
Yes, sir.
Yes, sir.
So 3D components को वॉल्यूम रहता है. यदि आपने प्रॉब्लम देखा होगा तो यहाँ पर क्या रहता है, डेंसिटी इज इक्वल टू क्या रहता है, मास अपॉन वॉल्यूम. तो उसको आपको वॉल्यूम की जरूरत पड़ती है. लेकिन 2D में रहेगा क्या, 2D में वॉल्यूम रहेगा क्या? नहीं. ड्यू टू दैट रीजन हियर आई हैव टेकन द डेंसिटी 0, डेंसिटी 0 लिया है. ठीक है. नाउ नेक्स्ट टू दैट, एज पर दिस प्रॉब्लम the left boundary is insulated, left hand side boundary is the insulated, matlab this boundary is insulated and 100 degrees temperature is at bottom. So you have to click on that, right click on this heat transfer module, and then you have to click on temperature. So you have to provide the temperature at bottom, and how much is the temperature? 100 degree centigrade. So here I will put 100, but आगे कौन सा यूनिट है, केल्विन है. So उसको आपको क्या करना है, यू नीड टू कन्वर्ट इनटू डिग्री सेंटीग्रेड. सो ड्यू टू दैट रीजन हियर DEGC मतलब क्या है, डिग्री सेंटीग्रेड. ओके. सो दिस इज द मेथड ऑफ गिविंग यूनिट, मतलब आप यूनिट कन्वर्ट करना चाहते हो तो यू कैन यूज दिस डिग्री सेंटीग्रेड. ओके. दिस इज द टेम्परेचर. ओके. आफ्टर दैट हियर if you will see, they have provided that the upper and right boundary are convecting 0 डिग्री सेंटीग्रेड एट हीट ट्रांसफर कोएफिशिएंट ऑफ 750. मतलब यहाँ पर क्या हो रहा है, हीट इज लूजिंग टू एनवायरमेंट. Okay, so here I will select another tab. So from heat flux, so कौन से बाउंड्री के ऊपर, यहाँ पर बाय डिफॉल्ट वो सिलेक्ट करता है बाउंड्रीज. तो यहाँ पर टॉप की बाउंड्री है और राइट हैंड साइड बाउंड्री. टू बाउंड्रीज आई हैव सिलेक्टेड एंड हियर यू कैन सी द फ्लक्स टाइप जनरल इनवर्ड हीट फ्लक्स. मतलब हीट अंदर जा रही है या बाहर जा रही है. तो यहाँ पर देखेंगे कन्वेक्टिंग हीट फ्लक्स दे हैव गिवन. So convecting heat flux, 1 minute, convecting heat flux. So how much is the heat transfer coefficient? 750. And temperature is what? Temperature we have provided 0. यहाँ पर आप क्या कर सकते हो, you can provide the unit of DEGC. Okay, next to that mesh built all. So यहाँ पर मेशिंग के यहाँ पर आएंगे तो यू कैन, ये सारे हमने क्या किया है, बाउंड्री कंडीशंस ऑलरेडी प्रोवाइड कर चुके हैं. यहाँ पर देखो मेशिंग में जाएंगे. सो यू कैन गिव द डिफरेंट टाइप्स ऑफ मेशिंग. मैंने क्या बोला था कि इफ़ यू आर डिवाइडिंग योर कंपोनेंट इनटू अ स्मॉल पार्ट, ड्यू टू दैट व्हाट विल हैपन, योर कंपटीशन टाइम ऑफ प्रॉब्लम विल इंक्रीज. मतलब आपके प्रॉब्लम को सॉल्व करने का टाइम इंक्रीज हो जाता है. जितना छोटा मेशिंग करेंगे उतना टाइम ज़्यादा लगेगा, बट जितना छोटा मेशिंग करेंगे उतने आपके रिजल्ट्स एक्यूरेट आएंगे. अभी ये नॉर्मल मेशिंग है, यहाँ पर जाएंगे तो फाइन मेशिंग भी कर सकते हो, फाइनर कर सकते हो, एक्स्ट्रा फाइन है, एक्सट्रीमली फाइन. ओके, और आपको कोर्स करना है मेशिंग तो यू कैन डू कोर्स मेशिंग ऑल्सो. इफ यू विल डू कोर्स मेशिंग योर कॉम्पिटिशन टाइम विल रिड्यूस, बट एक्यूरेसी विल व्हाट, एक्यूरेसी के ऊपर क्या इम्पैक्ट होगा कोर्स मेशिंग से? कैन एनीवन? हेलो, what is the impact of meshing on result if you will do so here what we will do, extremely fine meshing. So you can see the component is divided into a small part. Okay, and in study, so meshing part we have completed. You can do meshing likewise also, or different types of meshings are also there. You can give the pre-triangular meshing, pre-chord, map meshing also you can provide. If you so here if you want to the better results, or your component is what a complex component, you can use the pre-triangular and pre-chord meshing. Okay, if you want to do fine refinement of the corner part, that also you can do with the help of corner refinement. Okay, so for third year student there is the subject that is the CAE, computer aided engineering. So that सब्जेक्ट विल बी इन नेक्स्ट सेम. ओके, नेक्स्ट सेम में आपको ये सब्जेक्ट रहेगा, उसमें आपको एनसीएस के ऊपर ये प्रॉब्लम सॉल्व करनी है. सो आफ्टर कंप्लीशन ऑफ मेशिंग नेक्स्ट वी विल मूव टुवर्ड्स द स्टडी. नाउ हियर वी हैव टू क्लिक ऑन द स्टडी. ओके, सो हियर यू कैन सी we'll solve this problem. If you have provided all details correctly, it will solve problem, otherwise it will give error. अभी मैंने यहाँ पर देखो कि I have provided the fine meshing, so due to that reason it will take a little bit more time. So here you can see the what variable h is provided. h क्या provide किया आपने, यहाँ पर पूछ रहा है. So that I will remove. And then again I will solve. Again I will come here in study and compute. So actually this is the 2D problem, so less than 1 minute should be required for solving this problem. So here you can see this bar is showing your problem is solving now. Okay, so here you can see this window will show us so how heat is flowing. So here this color range will show us what At bottom it is the 280 degree Kelvin, and at top 370 degree centigrade Kelvin is there. So what I will do, I will change this color, because this this color should be in thermal. Now you can see here, but this temperature is in Kelvin. I want to convert that temperature in degree centigrade. So you can convert it into the degree centigrade also. So now this is the result part. In result parts, you can see this is the temperature tab, and next to that here you can see this is the isothermal counters. So these isothermal counters will show us, these counters shows the flow of heat. Okay, it will show us the flow of heat from this 100 degree centigrade to that heat flux. So यहाँ पर देखेंगे, so I will change first this unit. So if you want to change the unit, you have to click here and degree centigrade. मतलब यहाँ पर देखेंगे, so this red color, जहाँ पर red color है वहाँ पर कितना temperature है? Can anyone? How much temperature is at red color? Okay, so at red color you can see this 10 degree centigrade temperature is present at that red color. और maximum temperature कहाँ पर है? red hot कहाँ पर हुआ है देखो. So at bottom you can see this is the what 100 degree centigrade. At bottom पे हमने 100 degree centigrade temperature दिया था, वही हमें यहाँ पर मिल रहा है. और इस एरिया में क्या हो रहा है कि your heat is flowing from bottom to these two boundaries. Okay, वही होना चाहिए, क्योंकि heat is flowing from what higher temperature to lower temperature. Okay, so now if you want to see it in the form of arrows, यहाँ पर देखेंगे तो in results there are the various options are there. You can click on the arrow surface के ऊपर क्लिक करो, और you can click on the plot. तो यहाँ पर arrows आपको दिखाई देंगे. So that arrow shows us the direction of flow of heat. So मतलब heat is flowing from high temperature to low temperature. Okay, so if you want to increase the size of that arrow, you can increase the size of arrows. यहाँ पर देखो size of arrows increase किया आपने, तो यहाँ पर देखो. So your heat is flowing from where to where? कहाँ से कहाँ flow हो रहा है?
Bottom to top.
At bottom to top, or bottom to top and right hand side, because at that section you have provided the 0 degree centigrade temperature. यहाँ पर 0 degree centigrade temperature provide किया, and at that portion what will happen, the convention is occurring. convention हो रहा है, बराबर है ना, because that two sides are what, two sides are exposed to environment. Okay, so you can see the isothermal counters also. ओके, नाउ इफ यू वांट टू प्लॉट सम, कुछ स्टूडेंट बोलेंगे कि मुझे एक ग्राफ प्लॉट करना है इसका, कि हीट कैसे ट्रांसफर हो रही है, तो वो भी आप कर सकते हो. फॉर एग्जांपल, सो फॉर दैट पर्पस यू हैव टू राइट क्लिक ऑन द रिजल्ट्स, 1D प्लॉट करना है. देन अगेन यू हैव टू क्लिक ऑन दैट लाइन ग्राफ. ओके, सो यहाँ पर देखो, आपको समझो फॉर एग्जांपल यहाँ से यहाँ तक हीट कैसा फ्लो हो रहा है वो आपको चेक करना है. तो फॉर दैट पर्पस आई विल ड्रॉ 1 minute, आई विल ड्रॉ वन लाइन फ्रॉम हियर टू हियर, यहाँ से यहाँ पर लाइन में ड्रॉ करूँगा. ठीक है, तो वो लाइन ड्रॉ करने के लिए यहाँ पर आपको आना पड़ेगा. फॉर एग्जांपल यू नीड टू कम इन डेटा सेट. जो डेटा सेट रहता है इसमें आपको क्या करना है, यू हैव टू plot the line. So for that purpose, this is the problem of 2D. So I will take the cut line 2D. 2D problem रहेगा तो cut line 2D लेना है. 3D problem रहेगा तो you have to take 3D. Okay, so x ले लो, x axis. So I want to take this line. So I will take x is equal to 0. y कितना लेना है, y I will take 25. And then again the second point I will take here. Second point, width of that wall is the 0.6 and height will be the again 0.25. So here you can see the whether this line is plot. Okay, so here you can see this line is already drawn. Now I will select this 1D plot group, and this line is generated here in data set, and you can plot here. So here you can see the what is happening. So from 0 to 0.6, 0 to 0.6 में क्या हो रहा है देखो. At 0 you are getting what, 335 Kelvin. You can change the unit also. Kelvin में हम उसको डिग्री सेंटीग्रेड में कन्वर्ट करेंगे. ओके, सो इनिशियली यहाँ पर हाई टेम्परेचर कितना है, एट 0 डिग्री सेंटीग्रेड यू आर गेटिंग 0 डिग्री, सॉरी मैक्सिमम 60 to 65 के इन बिटवीन है, नियर अबाउट 63 डिग्री सेंटीग्रेड, और हियर यू आर गेटिंग व्हाट 14 to 15 डिग्री सेंटीग्रेड. ओके, सो दैट temperature distribution also you can show with the help of this software. Are you getting? या आपको थोड़ा हाई जा रहा है? Okay. So Naik sir. I'm audible to all of you?
Yes, sir. Yes, sir. You are audible, sir.
Okay. So next to that, here you can see this problem we have solved, as well as if you want to find out the temperature at any point, that also you can find out. For example, if you want to find out the temperature at this portion, यहाँ पर आपको find out करना, वो भी कर सकते हो. उसके लिए आपको क्या करना है, again you need to go into data set and you have to generate the point. तो कहाँ पर point generate करेंगे, cut point 2D. So यहाँ पर देखो x axis, मैं यहाँ पर टेम्परेचर चेक करना चाह रहा हूँ एट दिस पोर्शन. सो क्या करेंगे, x एक्सिस कितना लेना पड़ेगा आपको, x डिस्टेंस 0.6, एंड y कितना लेना पड़ेगा, y आई विल टेक 0.2. ओके, एंड देन आई विल प्लॉट. ओके, सो नाउ हियर द पॉइंट हैज बीन गेट जनरेट, एंड एट दिस पॉइंट आल्सो यू कैन फाइंड द टेम्परेचर. मतलब क्या रहता है कि कुछ समय पे आपकी रिक्वायरमेंट रहती है कि एट दैट लोकेशन आई वांट टू फाइंड द टेम्परेचर, सो वी कैन फाइंड दैट टेम्परेचर आल्सो. सो अगेन यू हैव टू राइट क्लिक ऑन रिजल्ट्स, 1D plot group, then again line, I will change the unit, that is the degree centigrade, and from data set I will take the cut line. I want to take cut point 2D, whether this point is generated. Now it is generated point. Okay, so here wait, what happened, cut point 2D. So at that point also you can take actually, so at that point also we can take the check the temperature. But what happened, I will see again 0.6 and 0.2 meter. So point we have plotted correctly in meter. Then next to that cut point 2D. Okay, so actually we can plot, try to plot in next example. Okay, बहुत सारे एग्जांपल्स हम लेने वाले हैं। तो यहाँ पर देखिए आपने हाउ द टेम्परेचर इज गेटिंग डिस्ट्रीब्यूटेड ओवर द डिस्टेंस और ओवर द थिकनेस, हाउ टेम्परेचर इज डिस्ट्रीब्यूशन, हाउ द flow of the temperature is flow of the heat is occurring from higher temperature to lower temperature, how the isothermal counters are generating on the this wall. Okay, so now we'll see the next problem, which is related with the, again this is the problem related with the inner surface of the plain brick wall is the 60-degree temperature at the one side location, and at outer side you can see the 35 degrees centigrade temperature. Here next to that we will see the calculate the heat transfer per meter square, heat transfer per meter square of the surface area of wall, which is the 220 meter thick. Actually this problem I have taken from R.K. Rajput book, which I think you are using in heat transfer. Okay. Next to that, here you can see the thermal conductivity of brick is how much? 0.51 watt per meters degree centigrade. Okay. So here the at one left hand side the 60-degree temperature, and at right hand side the 35 degree centigrade is there, and thickness of wall is how much? 220 mm. And this line is showing what? Temperature distribution, how the temperature is getting distributed from higher to lower temperature, as well as they have given the thermal conductivity, and they want to find the what? Rate of heat transfer. So that also we will find. Okay, so for that purpose, again here you have to open this new file, then this is the model wizard. Can anyone tell me the next step, what I have to select? Third year students, are you there? So can anyone tell me the next step, what I have to select as per this problem? Hello?
2D model.
2D. Why I have to select 2D? Because in problem as well as they have given the 2D. Okay, so 2D element I need to select. Then here recently which model you have used? Model you have used heat transfer in solids. So I will select a heat transfer in solids. I have added this. Now next study, and again stationary study, because we are not solving with time dependent. Okay, now next to that, in stationary, what is meaning of stationary? That also we have seen the in stationary what will happen, the temperature of component is not changing with respect to time. It can change with respect to distance, but it cannot change with respect to time. So due to that reason we have taken the stationary. So here this distance is in mm.
Hello,
So
sir.
here you have to select.
Your voice is breaking, sir. Hello.
Okay, okay. Hi, yes. You are audible, sir.
Hello, sir. Yes, sir. Your voice is breaking. Your voice is
Actually,
breaking little bit.
okay. So I'm using college internet.
Yes.
Okay.
Please, can you repeat that 1 minute presentation?
So okay. So here you can see this is problem which I have taken from R.K. Rajput book. In your syllabus also you have seen that you are using that heat and mass transfer by R.K. Rajput. So this problem is related with the conduction. The heat, the inner surface of the plain brick wall is the 60 degree centigrade. So inner wall, this side will be the inner wall, and this will be the outer wall of the brick wall. And the 60-degree temperature is at which side? Left hand side. And at right hand side, how much is the temperature? 35 degree centigrade. So calculate the heat transfer per meter square of the surface area. मतलब क्या है कि आपको क्या कैलकुलेट करना है? You have to calculate heat transfer per meter square or surface area of wall, which having the 220 mm the thickness. The thickness of that wall is how much? कितना है thickness? 220 mm thickness. So यहाँ पर देखो, and they have given the thermal conductivity. Thermal conductivity तो देना चाहिए, then only we can give the material properties. Or you, okay. So next to that, here this problem is solved theoretically. So we can validate theoretical answers with the simulation also. So here you need to click on the new, then model wizard, then 2D. reason behind to move to towards 2D, time का भी reason है, और in problem also they have mentioned solve by 2D. okay, so you have to click on heat transfer in solids. okay, next to that you have to click on study and stationary. Stationary क्योंकि और this problem is not time dependent problem, this is actually your temperature is constant. मतलब एक साइड 60 है, दूसरे साइड जो दिया है वो फॉर एग्जांपल 30 डिग्री दिया है तो 30 डिग्री रहेगा. टाइम डिपेंडेंट विथ रिस्पेक्ट टू टाइम यदि आप स्टडी करेंगे तो दैट टेम्परेचर विल वेरी एट बोथ साइड. सो हियर आई विल सिलेक्ट व्हाट लेंथ इन mm. इसका रीज़न क्या है कि दिस विड्थ इज 220 mm. ड्यू टू दैट रीज़न द ज्योमेट्री विच यू आर ड्राइंग दैट शुड बी इन mm. सो ज्योमेट्री, देन I will click on a rectangle. कितना है width 220 है, लेकिन इसका height दिया है क्या, height of that component, whether height is given, no. Due to that reason what we will do, we'll take height of, we'll assume the height, but that height should be the greater than the width. कितना होना चाहिए, तो यहाँ पर मैं 300 height ले लेता हूँ. okay, whether it is looking proportionate, no, so I will increase that up to 400. इसका इम्पैक्ट नहीं पड़ेगा कुछ. ठीक है, तो यहाँ पर देखो width is 220, height is 400. okay, now next to that here how much is temperature at this left hand side 60 degree and right hand side how much is the temperature, can anyone? right hand side how much is the temperature?
minus 35 degrees Celsius.
35 degrees centigrade. okay, so here I will move towards the physics, that physics is heat transfer physics, and here before this you can provide the material properties also. you can click on solids. आप डायरेक्टली मटेरियल लाइब्रेरी से भी ले सकते हो, लेकिन यहाँ पर क्या है कि थर्मल कंडक्टिविटी डायरेक्टली दिया है, इसलिए मैं थर्मल कंडक्टिविटी यहाँ से ले रहा हूँ. सो आई विल सिलेक्ट द सॉलिड and here you can see already it has selected the domain. एक ही डोमेन है तो एक ही डोमेन सेलेक्ट करेंगे. यहाँ पर मल्टीपल डोमेन्स रहेंगे. हम कंपोजिट वॉल का भी प्रॉब्लम देखेंगे एट दैट टाइम विल सी. यदि कंपोजिट वॉल का रहेगा तो वहाँ पर अलग अलग मटेरियल के वॉल्स रहेंगे. सो हियर यू कैन सी इन थर्मल कंडक्टिविटी विल बी द व्हाट यूजर डिफाइंड. सो थर्मल कंडक्टिविटी दिया है उन्होंने, दे हैव गिवन द 0.51 thermal conductivity, so I will provide the 0.51. density, how much will be the density for 2D, can anyone? 0, user defined 0. यदि आप 3D ड्रॉ करेंगे तो वो एरर दिखाएगा. 3D में आप डेंसिटी 0 नहीं दे सकते हो, क्योंकि 3D हैज़ व्हाट वॉल्यूम, एंड डेंसिटी का फॉर्मूला हमें पता है, रो इज इक्वल टू मास अपॉन वॉल्यूम. तो ये हियर वी हैव गिवन द मटेरियल प्रॉपर्टी एंड यहाँ का क्रॉस निकल चुका है, देखो अभी. Next to that, thermal insulation. So already the problem has provided the thermal insulation, but हमने boundary conditions अब तक दिए हैं क्या? Whether we have provided the boundary conditions? No. What is the boundary conditions? So left hand side 60 degree centigrade and right hand side 35. So I will provide that. Two temperatures. एक temperature ले लिया, second temperature. ठीक है, पहला टेम्परेचर, फर्स्ट टेम्परेचर आई विल सिलेक्ट दिस, एंड टेम्परेचर वी नो 60 डिग्री. तो स्क्वायर ब्रैकेट DEGC. देन नेक्स्ट टू दैट सेकंड साइड यहाँ पर सिलेक्ट किया. हाउ मच इज द टेम्परेचर एट सेकंड साइड? 30 है ना, 35 DEGC. then we have provided the all boundary conditions. Other than that, whether anything is present in this problem, no. यहाँ पर ओवरऑल हीट ट्रांसफर कोएफिशिएंट ऐसा कुछ दिया ही नहीं है. ठीक है, सो टोटली दिस इज रिलेटेड विद द व्हाट कंडक्शन प्रॉब्लम, कंडक्शन का प्रॉब्लम. तो यहाँ पर देखो मेशिंग करना है तो मेशिंग आल्सो यू कैन प्रोवाइड बाय डिफॉल्ट करना है बाय डिफॉल्ट कर सकते हो, अभी बाय डिफॉल्ट ही करेंगे। आपको यदि टाइम आपके पास है तो यू कैन चेंज इट एंड यू कैन सिलेक्ट। So it is my request to all students, you have to download this COMSOL Multiphysics software in your laptop and you can start to solve such problems. So at the end of these sessions, I expect that at least third year student, all students have to solve at least 5 problems by using this software and submit it to Nike sir. Okay, that will be the outcome of this project, outcome of this lecture. Okay, so यहाँ पर देखो meshing, then meshing हो गया, then you have to click on study. Which study we have selected? Stationary, and then you have to click on complete. So actually this is the what numerical method based software. So यहाँ पर जब भी प्रॉब्लम सॉल्व हो रहा होगा तो यहाँ पर देखो प्रोग्रेस में क्या चल रहा है, लॉग में क्या चल रहा है। So जो भी आप प्रॉब्लम सॉल्व कर रहे हो, for example whatever problems you have solved in numerical methods, all these numerical methods are used here. जो भी आपका रोंजे गुट्टा रहेगा वो भी यहाँ पर यूज़ किया जाता है। यदि आप इसका सॉल्वर का कॉन्फ़िगरेशन देखेंगे तो इसमें आपको सब पता चलेगा, डिपेंडेंट वेरिएबल्स क्या रहते हैं, स्टेशनरी, एडवांस, इसमें कौन कौन से मेथड्स रहते हैं। ओके, टाइम डिपेंडेंट में आप कौन कौन से आपके रोंजे गुट्टा यूज़ करते हो, ट्रापेजोइडल मेथड्स आल्सो यू आर यूजिंग हियर। ओके, so now problem has been solved. Now here you can see the results. By default software result will provided here. So here you can see I will change the color. सरफेस में जाके यहाँ पर आपको क्लिक करना होगा। You can use the thermal color. Okay, so here you can see this red hot will show us what higher temperature. यहाँ पर आपको higher temperature मिल रहा है, at this portion you are getting lower temperature. रेनबो भी आपको यूज़ करना है तो यू कैन यूज़ रेनबो ऑल्सो। ओके, सो हायर टेम्परेचर विल बी एट दिस पोर्शन एंड लोअर टेम्परेचर ब्लू कलर विल शो अस व्हाट लोअर टेम्परेचर। ओके, सो नाउ हाउ हीट इज फ्लोइंग, कैन एनीवन टेल मी हाउ हीट इज फ्लोइंग? If you want to show the maximum temperature and minimum temperature, that also you can show. So I will put here the units, डिग्री सेंटीग्रेड। सो मिनिमम टेम्परेचर इज 35 डिग्री। आपको पता है आपने दे दिया है 35 डिग्री और इनिशियली एट दिस पोर्शन 60 डिग्री टेम्परेचर इज दिया। सो आइसोथर्मल काउंटर इज आल्सो प्रेजेंट। ओके, नाउ इफ यू वांट टू शो द डायरेक्शन ऑफ हीट फ्लो कैसे होगा यहाँ पर? कैन एनीवन?
Right to left.
So heat will be flow from left hand side to right hand side. So यहाँ पर देखो मैंने यहाँ पर एरो सरफेस लगा दिया है, एरो विल शो अस टेम्परेचर डायरेक्शन, सॉरी हाँ टेम्परेचर डिस्ट्रीब्यूशन ऑल्सो और डायरेक्शन ऑफ हीट फ्लो। हीट का फ्लो कैसे हो रहा है, हायर टेम्परेचर टू लोअर टेम्परेचर। इफ़ यू वांट टू इंक्रीज द साइज और नंबर ऑफ, यदि आपको एरोज इंक्रीज करने हैं तो भी आप इंक्रीज कर सकते हो। हियर ठीक है, साइज इंक्रीज किया तो बहुत सारे एरोज आ रहे हैं। सो व्हाट आई विल डू, ठीक है, इफ़ यू वांट टू चेंज द एरो यू कैन चेंज द एरो हेड। कोन में भी आप कन्वर्ट कर सकते हो। यहाँ पर देखो मैंने कोन अभी यूज़ किया है, सो इट विल शोज द डायरेक्शन। नाउ नेक्स्ट टू दैट, इफ़ यू वांट टू चेक द टेम्परेचर डिस्ट्रीब्यूशन, दैट आल्सो यू कैन चेक। टेम्परेचर डिस्ट्रीब्यूट कैसे हो रहा है वो भी आप चेक कर सकते हो। फॉर दैट पर्पज यू हैव टू सिलेक्ट द 1D प्लॉट, अगेन द 1D प्लॉट। तो यहाँ पर क्या आ चुका है, टेम्परेचर। आई विल चेंज द यूनिट, that is the degree centigrade. Next to that, here you have to select what area on which you want to check the temperature distribution. So I want to check at middle portion पे मुझे check करना है तो that I will check. For that purpose again I have to go for data set. पिछले problem में हमने देखा था, so data set, cut line 2D, first point x axis will be 0, y will be the, how much will be the height, 200 mm, then x we are shifting 220, मतलब ये thickness कितना है, 220 है, and height will be the 200. Okay, so here we can see the at center we have drawn this line, and then I will select it. Cut line 2D. Okay, so here you can see that this will show us what, this is shows the temperature distribution. आपने temperature distribution यहाँ पर देखा होगा, वैसे सेम आ रहा है, मतलब your heat is flowing from higher temperature to lower temperature. But in that question they have asked what, the calculate rate of heat transfer. So that also we can calculate rate of heat transfer. So I will calculate the rate of heat transfer. So for that purpose again you have to go into results, then 2D plot group, again you have to take surface area. Okay, so I will move towards 2D plot group. So यहाँ पर देखेंगे तो by default it has taken the temperature, but I want to find out what, मुझे क्या find out करना है, what I have to find out, can anyone? What I have to find out? Are you there?
Rate of heat transfer.
Rate of heat transfer per meter square. Okay, so here what I will do, I will move in expression, here you will get two arrows. So with the help of that two arrows you can check the any points, मतलब आप यहाँ पर डोमेन फ्लक्स है, डोमेन फ्लक्स से आप चेक कर सकते हो कन्वेक्टिव हीट ट्रांसफर मैग्नीट्यूड है, टोटल एनर्जी फ्लक्स है, टोटल हीट फ्लक्स है, टोटल एंथैल्पी फ्लक्स है, कन्वेंशन में जो पैरामीटर्स रहेंगे वो भी आप चेक कर सकते हो. Okay, so here what I have required the total heat flux. So I will select total heat flux and I will click on the plot. Okay, so what results I am getting here? So यहाँ पर आपको results क्या मिल रही है, देखो 57.95 watt per meter square, that much total heat flux is present here. And at lower blue color it will indicates at the lower heat flux is present at this left hand side, and at right hand side you will get maximum heat flux. Okay, whether it is correct, so that we will check. Theoretical कितना आया है हमारा, how much is the theoretical answer of heat flux, Q कितना आया है हमारा, how much is that value, theoretically कितना आया है, can anyone theoretically how much heat flux you are getting, 57.95. Okay, so here what we will do, theoretically we can compare. theoretically कितना आया था, 57 point something आया था, तो यहाँ पर देखो by using that simulation software you will get 57.95, that much heat flux you are getting or heat flow rate you are getting. Okay, so here also we have seen the temperature distribution as well as the total heat flow rate or total rate of heat flow per unit watt per meter square. Okay, तो यहाँ तक हमने देखा. Next to that same problem is there, but by changing the thermal conductivity. Okay, so same problem also we can solve, but once again I will solve this problem. So are you there, all of you?
Yes, sir.
Yes, sir.
So here you can see the thermal conductivity of copper and silicon material. So you can see this is the what, this is the first image shows the wall, same dimension is there, same temperature is there. I think only change in copper and silicon thermal conductivity. Okay, क्योंकि different material has the different thermal conductivity. Okay, you know the effect of the temperature or effect of various parameter on the temperature. I think that also, that part also you have learned in that heat transfer. Okay, so now next to that here you can see I will draw and we'll try to find the results, whether we are getting the same result or different results. मतलब हमें क्यों find out करना है इसमें. ठीक है, जैसे हमने अभी के प्रॉब्लम में किया था. So again, what procedure I need to follow? Model wizard, 2D, then heat transfer in solids. Next to that, we'll select the stationary because it is not time dependent. We'll solve one problem on time dependent that is related with laminar flow. But at the end of this session, we'll solve this. Okay, so how much is the width? 1 meter, and height will take 3 to 4. Okay, because height they are not given. So in rectangle, the width will be how much? 1 meter, height will give 3 meter, and I will build this model. Are you getting how I am drawing this geometry? Geometry कैसे draw कर रहा हूँ, समझ में आ रहा है क्या सबके?
Yes, sir.
क्योंकि ये सिंपल स्टेप्स कर रहा हूँ मैं ज्योमेट्री जनरेट करना, क्योंकि फॉर रेक्टेंगल व्हाट इज रिक्वायरमेंट, विड्थ एंड हाइट इज रिक्वायर्ड. ओके, नाउ नेक्स्ट दैट आई विल मूविंग टुवर्ड्स द हीट ट्रांसफर मॉड्यूल. Okay, so by default it will select what that domain. Then here I need to move in solid one. Reason behind to provide the what, क्या प्रोवाइड करना है हमें? थर्मल कंडक्टिविटी. So यहाँ पर देखेंगे थर्मल कंडक्टिविटी है. So for same model you can use the different thermal conductivity also. That also we'll see in this numerical method problem. Thermal conductivity कितना है? 401. So I will provide the 401. Next to that, thermal insulation. By default it will take thermal insulation to all sides, but हम निकालते हैं कैसे, यहाँ पर देखेंगे. So here the higher temperature is this side and lower temperature is this side. जब हम टेम्परेचर देंगे तो इंसुलेशन वो बाय डिफॉल्ट निकाल देगा. So I will take two temperatures. So temperature 1 is how much? 30, 20. So this is the 30-degree temperature, and here will be the 20-degree. Temperature. Next to that, okay, we have to select the left right hand side also. Select किया मैंने. Now next to that we'll do meshing. Now I will do the map meshing. इसको मैप मेशिंग कर देते हैं. मैप मेशिंग का इफेक्ट देखो यहाँ पर. यदि आपको मेशिंग प्रॉपर मेशिंग करना है तो यू कैन यूज दिस मैप मेशिंग आल्सो, एंड देन आई विल सॉल्व दिस प्रॉब्लम. If I have provided the all parameters correctly, it will solve within fraction of second. कितने सेकंड में सॉल्व कर रहा है? 12 सेकंड में इसने सॉल्व किया. ठीक है. सो हियर आई विल यूज द रेनबो कलर. यहाँ पर रेनबो कलर यूज कर रहा हूँ. हीट कैमरा से भी आप अलग यदि आपको कलर्स देने तो यू कैन प्रोवाइड हियर व्हाट, यू कैन प्रोवाइड द रेनबो. So here you are getting at red portion you will get the maximum temperature of 303 Kelvin and minimum temperature of 294. If you want to check the maximum minimum, so here you have to come temperature and show maximum minimum along with units. So if you want to change the unit, you can change the unit to degree centigrade. Okay, so maximum temperature of 30 degree and minimum temperature of 20 degree. तो आपने ऑलरेडी दे दिया था यहाँ पर कितना टेम्परेचर दिया था. हाउ मच टेम्परेचर यू हैव प्रोवाइडेड फॉर लेफ्ट हैंड साइड? हाउ मच टेम्परेचर यू हैव प्रोवाइडेड? आर यू देयर? All of you, are you there?
Students, are you there? This session is for
Yes,
you,
sir.
not for us.
So here at left hand side we have given the 30 degree temperature, and at right hand side we have provided the 20-degree temperature. Okay, then isothermal counters also we can see here. Now next to that, we can show here the temperature distribution also. For that purpose you need to click on 1D plot, and here for that purpose you have to provide the data set of 1D cut line, 2D cut line. So 0 0 y-axis will be the 2. How much height we have provided for this problem? Geometry में जाके देखना पड़ेगा. 3 provide किया है. So I will provide here y will be the 1.5. X-axis how much? 1. Y will be the 1.5. So यहाँ पर line एक draw हो जाएगा. देखो, this line has been drawn. So we can see the stress temperature distribution. So how? So here we have to select the cut line 2D. So here with the help of this line we can see the how temperature is flowing, or how the heat is flowing from higher to lower. Okay, here I will change the unit. Okay, now next to that here, what we have to see the how much heat is flowing from inner portion of this wall to outer portion. So that also we can show with the help of results. 2D plot we need to click again 2D plot, and here by default it will select what temperature, but I want to show heat flow rate. So you have to right click on that 2 arrow and domain flux. So here total heat flux I will select, and I will see here 4.01 into 10 raised to 3 बराबर है. So उतना ही आंसर यहाँ पर है. So here I will, so it is 10 raised to 3, so I will change this number format. So for that purpose you have to click on that 2D plot group, and here we'll take the precision of 5. Okay, so here you can see the 4010 watt per meter square. So, and by theoretically how much value you are getting? 4010. Whether it is correct, have you done the validation correctly? मतलब हम जो प्रॉब्लम सॉल्व कर रहे हैं theoretical answer we can compare by simulation software. With the help of simulation software we can compare. Are you getting? जो आप प्रॉब्लम theoretically सॉल्व कर सकते हो, that same problem we can solve by using this simulation software. Okay, so we have seen the temperature distribution, we have seen the heat flux, or how much heat is flowing from inside to outside. Okay, now next to that we'll see the how to give a different material properties. Okay, यहाँ पर देखो material properties आपको दे देने, so you can provide the different material properties also. Actually here they have given the two different 148. So again you need to give what material property. 4010 हमने सॉल्व किया है. Sorry, we have solved for copper. Now we'll select for silicon. So how much is the conductivity of that silicon? 148. Okay, and we'll compute it again. Same problem or different thermal conductivity. Okay, so now here minimum temperature is 20 degree and maximum is 30. So we can see the temperature distribution also, and we can see the heat flow rate. How much is the heat flow rate? 1480. And theoretically how much is the 1480? Okay, so whether we have done the validation of this problem. तो यहाँ तक हमने validation कर दिया है. Wait, Mike sir, are you there?
Yes, sir. Yes, sir.
Okay, so how much time shall we conduct Next 10 minutes.
Yes, sir. Yes.
Actually, less students are there. We can.
Yes, sir. Actually, 44,
Okay,
45
we'll
students
take
are available.
more 10 minutes and we'll
So
solve.
if you take any one example on
I have taken
convection, it will
actually
be okay.
near about 10 problems, but okay, so we'll solve one more problem of
Sir, can you
composite.
take one example on convection?
Yes, sir. Yes, sir. We'll take one problem of
That
convection
will
for
be better.
composite wall. Okay, so the
Yes.
actually this is problem of
Yes.
composite wall with convention. Okay.
Okay.
So here you can see this is the composite wall. Calculate the rate of heat flow rate per meter square through the furnace wall consisting of 200 mm thickness. Inner layer is made up of from chrome brick. Central layer is made up of from kaolin brick, and the outer layer is made up of from masonry brick. The unit surface conductance of inner surface is 74 watt per meter square, and the outer surface is 70 degrees temperature. The temperature of gases inside the furnace is the 1617 degrees centigrade, and what temperature prevails at the inner surface and outer surface of the center. So we can find the what, as per this problem here you can see we can find the temperature at T1 location, T2 location, T3 location, T4 location. At different location we can find temperature. Okay, so here what will happen, this is the actually composite wall, and the inside this composite cylinder the gas is stored. So what will happen in between the gas and this chrome brick, there will be the convection will occur. So due to that reason here they have given the temperature and overall heat transfer coefficient. Okay, 74 watt per meter square degree centigrade. Okay, so we'll try to solve these problems. So model wizard, again I will select the 2D, then heat transfer in solids, then study, then stationary again, because it is not time dependent. We'll take time dependent problem also. So here you can see, so by default the geometry tab, the length unit is meter, so I will select mm because in problem they have given the units are in mm. So I will select the rectangle. 200 mm is what width, and height will be the what 400. So 200 mm is the width and height. I will select the 400. So now one rectangle has been get generated. Second will be the what of thickness 100 mm. So same I will duplicate. So you can right click on that and can do duplication. You can build all objects. Okay. So यहाँ पर देखो, you want to you have generated the second rectangle, but it is overlapping to this. So you need to shift from x-axis. So how much x distance you have to take 200. तो अभी ये shift हो चुका है, लेकिन thickness of that middle wall is how much 100 mm. Okay, so we'll provide the width of 100. Yeah, again I will generate one more rectangle with duplicate option. Okay, I will shift it by 100. Now you can see the three walls are created here, three composite walls are created here. Okay, so I will provide the thermal conductivity of each wall. Already the thermal conductivity of each wall is given. Okay, so we'll provide the thermal conductivity. So solid 1 duplicate और एक solid ले लेते हैं. Three material के लिए three different solids. So solid 3, this will be for material 3. मिडल के लिए सॉलिड 2 इसके ऊपर सिलेक्ट करेंगे तो बाय डिफॉल्ट इट विल सिलेक्ट सॉलिड 1. ओके, सो आई विल गिव मटेरियल प्रॉपर्टीज टू सॉलिड 1. User define. How much is the thermal conductivity of inner material? 1.25. So I will provide here 1.25. And the density of the that material is 0. Next to that, a material 2. So thermal conductivity of material 2 is how much? 0.074. And density will be again 0 because these components are what? 2D components. There is no requirement of, it has no thickness. 2D component has no thickness. Due to that reason also we are not providing the density. This is what thermal conductivity of third component. अभी क्या किया है कि सेम प्रॉब्लम वी आर सॉल्विंग बट नंबर ऑफ वॉल्स आर इंक्रीज. ओके, नहीं तो आप बोलेंगे कि थर्मल कंडक्टिविटी आप 3 क्यों दे रहे हैं. तो दिस इज द कॉम्पोजिट वॉल प्रॉब्लम. इन कॉम्पोजिट वॉल प्रॉब्लम्स द these walls are sequentially attached to each other to avoid the heat flow rate. So third will be the point 555. Density will be 0. Heat capacity will be 0. Okay, mesh. We'll do normal meshing only. Okay, we have done all things, but we have provided only thermal conductivity. Other properties we need to provide. Okay, so here if you'll see the convection is occurring here. So here you can see HF is what? Overall heat transfer coefficient is 74, and temperature of gases is how much? 1670. So due to that, temperature at inner wall will be different. At in between this kaolin and the chrome brick will be different. Kaolin bricks and masonry brick will be different. Okay, so that also we can find. Okay, so what we'll do, we will provide the temperature with the help of heat flux option. So I will select this point. General, I will select the convective heat transfer, heat flux, because the in between the gas and this wall there will be the what? Convective heat flux will be there. How much will be that? H 74. How much will be the temperature? 1670. Okay. So we have given the properties of the convention here to inner side. Now next to that we'll see at outer boundary what properties we need to provide. So here is okay. So calculate the rate of heat flow rate for furnace wall consisting of 200 mm is the inner thickness of chrome brick, center brick is 100 mm, outer layer is 100 mm thick, and unit surface conductance is 74. Already we have provided that. Outer surface temperature is 70 degree temperature. So outer surface temperature also we need to provide. So here I will provide the 70 degree temperature. Okay, now I think all properties we have given. We have done the meshing, so we will solve this problem and we will see whether this problem will solve successfully or not. Okay, so one more problem we will take. Actually I want to take one problem on pin also, but due to time being we'll try to solve one problem of CFD, computational fluid dynamics. Okay, now problem has been solved here. I will change the color, then we'll do rainbow color. Okay, so here you can see the nearer to this gas area you will get the more temperature, that is near about how much temperature is there. We'll convert into a degree centigrade and we'll change the number format also. so we can read easily. Number format also you can change. Okay, so here you can see the temperature is maximum temperature is 1657.3 of this wall. Okay, inside wall. Outer wall का कितना है? Near about 70 degree temperature. Already we have provided 70, but T1 temperature also we can find out. Okay, isothermal counter also you can see here. You can see the direction of flow of heat also. Direction of flow of heat also. You know the temperature is flowing from or that heat is flowing from higher temperature to lower temperature. Okay, so here you can do that temperature distribution also. Already we have seen, so you can do that at home also. Now next to that, if whenever you are downloading that, at that time also you can do that. Okay, now next to that I want to show you temperature, how to find the temperature of middle wall. Okay, so for that purpose you have to select the result portion and numerical data for point evaluation. Rather than point evaluation, what we will do, we will select the edges. I want to find the temperature, average temperature on edges. So I will select the 2D edge for first. Again I will select the more edges. Second for this edge. Third will be for second and third component interface. And at last, you know the how much is temperature, 70 degree. Okay, so I will select this first edge or first, second for second edge, third data set for third edge. Okay, now what I will do, I will select more derived values or line average. Okay, so here you can see first I will select the edge 2D1 or this first edge. How much is the temperature? Actually the gas temperature we have provided. Okay, gas temperature we have provided. How much is the gas temperature? Gas temperature is 1670. Okay, but I want to find the temperature of this wall. So with the help of this we can find out. So this is the 1930.5 or Kelvin. If you want to find in degree centigrade, you can find. Okay, तो यहाँ पर देखेंगे 1657.3 is the temperature of inside wall. Okay, now next I want to find out for this middle wall. उसके लिए आपको second edge select करना पड़ेगा. Then I will select the unit properly. So here you can see 1507.2 for the that is the temperature in between chrome brick and kaolin brick, T2 temperature. Now I want to find out the T3 temperature, that also we can find out. For that purpose I need to select one more line and then I have to select the edge. Okay, so I will change the unit. Okay, so that temperature is 239.08. Okay, so here you can see the temperature is also decreasing from inner to outer wall. Reason behind this is the thermal conductivity of this composite wall, or thermal conductivity of different material is different. So यहाँ पर क्या होगा, और what is the function of composite wall? To reduce the heat flow rate. So here also you can find out the heat flow rate. Heat flow rate भी आप find out कर सकते हो इस problem. ठीक है. So now next to that we will see the one problem on laminar flow. How many students are there? 24. Okay. So one more problem we will see, that is related with what? CFD, computational fluid dynamics. ये थर्ड ईयर के स्टूडेंट के लिए तो बहुत इंपॉर्टेंट है. इसके ऊपर एक थियरी क्वेश्चन या प्रॉब्लम रहता ही है. So here I will select the 2D. Then actually this diagram is 2D diagram. So I will select the 2D component, 2D elements. So here you need to come into fluid flow, single fluid flow, and then laminar flow. I will add this laminar flow and then study. So first I will take the stationary and then we'll see the time dependent also. Okay, hardly it will take 10 minutes. Okay, so here we'll see the how much is what is the dimension of this pipe. Actually this is the laminar flow through a rectangular pipe. This is what inlet of this pipe, this will be the outlet of this pipe. Okay, and this is the what obstacle which we have kept inside this pipe, and due to obstacle what will happen, what is the impact of this obstacle on the pressure as well as the velocity distribution inside the pipe, that also we can check. Okay, so how much is the dimension, the width of, so here you can see the width of that pipe is 2.2 and the height will be the 0.41. Okay, so here you can see a rectangle. So width will be the 2.2, height will be the 0.41 meter. ये सारे यूनिट बाय डिफॉल्ट मीटर में है. Then next to that, here I will select the one, I will take one obstacle of circular geometry. 0.04 is the radius. So when I will select it, it will select at corner. So now I have to shift it at center location. So कितना shift करना पड़ेगा? 0.25 and 0.41 divided by 2. So x कितना होना चाहिए? That should be the 0.25 and y should be the how much? 0.41 divided by 2. क्योंकि उसका height कितना है? Height of this pipe, rectangular pipe is 41. Okay, so now it is shifted, but I want to delete this circular obstacle. कैसे delete करेंगे? Can anyone? How to delete it? कौन सा ऑपरेशन यहाँ पे यूज करना पड़ता है? By right clicking on geometry, you can select the boolean operation. ये सारे ऑपरेशन हो चुके हैं. यदि आपने AutoCAD सीखा होगा या आपने मैथमेटिक्स सीखा होगा, ये सारे हमने ऑपरेशन सीखे. ठीक है. So with the help of difference, we can delete that center portion. So I have selected whole geometry. Then I want to select the circle. So here also we can check the impact of the changing the diameter of that obstacle on that velocity flow distribution as well as the pressure distribution. वो भी हम check कर सकते हैं. ठीक है. Now we have generated the object. Next is what? Laminar flow. This is what our physics. Now here I will select the material. So here I will generate the blank material. In COMSOL Multiphysics you can generate the blank material. Blank material generate कर सकते हो, और whatever properties are required for this physics, that properties will be taken by this model. तो यहाँ पर देखो इसको क्या चाहिए? Density चाहिए, क्योंकि इसके अंदर से क्या जा रहा है? Flow of this flow through this pipe will be of water flow हो रहा है या air हो रहा है, that you can give with the help of this blank material. So here, so I will consider here the air as the fluid. So density of the air is how much? Density कितना रहता है? How much is the density of air? How much is the density of air in kg per meter square, meter cube? How much is the density? बोलो. 10. How much is the density? Can anyone?
Prathamesh, Vijay.
How much is the density of air?
Yes, anyone?
Sir,
Yeah,
1 point
fine.
something.
1 point
1
something
point
means what?
something.
What is 1 point something?
Okay, and what is the
1.2.
dynamic viscosity? Dynamic viscosity of air. I think you have learned in fluid mechanics. और ये हमेशा आपको याद रहना चाहिए, व्हाट इज द डेंसिटी ऑफ एयर, व्हाट इज द डेंसिटी ऑफ वाटर, व्हाट इज द डेंसिटी ऑफ मर्क्यूरी. ये तो स्टैंडर्ड है, ये तीनों का हमें पता होना चाहिए. 1 into e⁻⁻3. Okay, that is the dynamic viscosity. Okay, next I have given all material properties. Now next to that, all fluid properties can be taken from this material. If you will come into fluid property, यहाँ पर देखेंगे. So from material it will take all properties. Okay, and this fluid is considered as Newtonian fluid. What is meant by Newtonian fluid? Can anyone?
Obvious Newton law of viscosity.
So here you can see these fluid are also considered as incompressible fluid. So that is our assumption. Next to that, here we can see this is the rectangular pipe through which what air is flowing, and one circular obstacle has been kept here. So we'll check what velocity flow as well as the pressure flow. So first I will give you inlet outlet to this pipe. So right click करो, inlet यहाँ पर देखो how much is the inlet of this, where is the inlet. तो यहाँ पर inlet होना चाहिए. How much is the velocity, velocity कितना होना चाहिए, that is also I have given here. 1 meter per second, that velocity we are considering. Actually this velocity is depends on what Reynolds number. Reynolds number का फॉर्मूला क्या है, R E is equal to what, rho VD divided by mu. डेंसिटी ऑफ एयर तो क्या होगा, कॉन्स्टेंटली सेम ही रहेगा 1. रो वी डी, डी इज द डायमीटर ऑफ दिस पाइप, डायमीटर भी कांस्टेंट रहेगा, म्यू भी कांस्टेंट रहेगा. तो वैरी क्या होगा, द वैरी विल बी द वेलोसिटी ऑफ द एयर. तो वेलोसिटी के ऊपर ये रेनॉल्ड्स नंबर यहाँ पर डिपेंड है. वेलोसिटी आप चेंज करेंगे तो इट विल कन्वर्ट्स फ्रॉम लैमिनार टू टर्बुलेंट, टर्बुलेंट टू ट्रांजिएंट. ओके, सो हियर आई हैव प्रोवाइडेड द 1 meter per second is the velocity. Outlet we will provide at outlet portion. Okay, now inlet outlet we have provided, as well as here we can see what we can give other properties. तो सारे प्रॉपर्टीज हमने दे दिए. नेक्स्ट आई विल डू मेशिंग. नॉर्मल मेशिंग करना है नॉर्मल कर सकते हो. इफ यू वांट टू कन्वर्ट इट इनटू द फाइन मेशिंग, फाइन मेशिंग भी कर सकते हो. Okay, so here you need to click on study and click on complete. It will take little bit time. Here you can see the conversion plot. So it will, what it will do, आपने यहाँ पर देखे होंगे. So हमेशा मैं बोल रहा था कि this software is depends on what numerical methods. So what it will do, it will reduce the error. For example, at this portion the maximum error is there, and while solving this problem it will try to reduce the error. मतलब आप जब भी न्यूमेरिकल मेथड्स के प्रॉब्लम सॉल्व कर रहे होते हैं, आप हमेशा क्या करते हो कि यू आर रिड्यूसिंग द ईयर, यू आर ट्राइंग टू रिड्यूस द ईयर. आपको रिजल्ट्स एक ही स्टेप में मिल जाते हैं, फिर भी आप क्या करते हो कि यू आर इंक्रीजिंग द नंबर ऑफ स्टेप्स एंड यू आर मूविंग टूवर्ड्स द एक्यूरेसी. मतलब आप एरर रिमूव कर करके आगे जाते हो. तो सेम यहाँ पर पूरा न्यूमेरिकल मेथड यूज किया जाता है. यहाँ पर एरर रिमूव किया है एंड लास्टली दिस सॉल्यूशन इज गेटिंग कन्वर्ज हियर. सो एप्लीकेशन ऑफ न्यूमेरिकल मेथड यानी ऐसे हम जो सब्जेक्ट है उसका एप्लीकेशन यहाँ पर भी है, इस सॉफ्टवेयर में भी है. तो यहाँ पर देखेंगे तो this pattern you are getting here, and here you can see this is the what velocity versus distance. मतलब velocity is showing on y-axis and on x-axis the length of the pipe is showing. Already we have given the 2.2 meter is the length of the pipe, and this is the velocity. मतलब at inlet we have provided the 1 meter per second velocity. Okay, so यहाँ पर देखेंगे the at inlet you are getting the 0.8 or 1 meter per second velocity, बट ड्यू टू ऑब्स्टेकल की वजह से यहाँ पर क्या हो चुका है, देखो हियर द velocity of that air has been increased, but at the back end of that obstacle you can see the how much is the velocity, कितना velocity है, कोई बताएगा मुझे यहाँ पर कितना velocity है at this portion आपको ये स्केल रीड करने को आना चाहिए। देखो at this
Zero.
bottom 0 velocity is there, at top you can see 1.4 meter. If you want to see maximum and minimum you can click here. Okay, 1.55 meter per second is the highest velocity and 0 is the lowest velocity. Now if you want to check the velocity pattern check करना है तो वो भी देख सकते हो। और आपने देखा होगा कि यहाँ पर क्या रहता है कि at the nearer of this pipe how much is the velocity, at the nearer कितना velocity है, यहाँ पर कितना velocity है,
Zero.
0। रीजन बिहाइंड दिस कोई बताएगा मुझे कि वहाँ पर 0 वेलोसिटी क्यों है, कि फ्लूइड मैकेनिक्स में आपने देखा होगा व्हाई द वेलोसिटी एट द नियरर ऑफ पाइप इज 0। सो ड्यू टू फ्रिक्शन दैट वेलोसिटी विल बिकम व्हाट, 0। फ्रिक्शन की वजह से क्या होता है, फ्रिक्शन इन बिटवीन एयर एंड पाइप दैट विल बिकम 0। सो वी विल चेक हाउ द वेलोसिटी पैटर्न इज प्रेजेंट। So what we will do, we will try to take 1D line. Again I will take 1D plot. I will select a data set and we will select a 1D line tool, cut line 2D. Okay, x axis will be 0, y कितना लेना पड़ेगा, at center we are getting, so I will select the 0.3, x will be the 2.2, y will be the what, y will be the 0.2. okay, so you can shift that also, आगे भी आप शिफ्ट कर सकते हो तो आपको रिजल्ट बेटर मिलेंगे। okay, because we have seen the maximum velocity has increased at nearer to this obstacle. Again you have to click on 1D plot group, cut line 2D. so here you can see at initial मतलब at starting of the pipe you are getting how much velocity, you are getting what, less velocity, or you can see 1 मीटर पर सेकंड, मतलब हमने दिया ही था 1, बराबर है ना, 1 मीटर पर सेकंड मिल रहा है, लेकिन एट नियरर टू दैट 0.25 डिस्टेंस पे हमने क्या रखा था, ऑब्स्टेकल रखा था। तो ऑब्स्टेकल की वजह से क्या हुआ है यहाँ पर, दैट वेलोसिटी हैज बीन इंक्रीज टू 1.45 मीटर पर सेकंड, and after the obstacle that velocity has been getting decreased. okay, so that also you can see, again you can see प्रेशर डिस्ट्रीब्यूशन, आप प्रेशर डिस्ट्रीब्यूशन भी चेक कर सकते हो, उसके लिए आपको वर्टिकल लाइन ड्रॉ करना पड़ेगा। सो अगेन आई विल ड्रॉ लाइन, दिस इज द वेलोसिटी डिस्ट्रीब्यूशन। प्रेशर डिस्ट्रीब्यूशन के लिए हमें ओके एट स्टार्टिंग हम प्रेशर डिस्ट्रीब्यूशन चेक करेंगे। ये वेलोसिटी चेक, वेलोसिटी सिलेक्ट किया है बाय डिफॉल्ट। सो फॉर दैट पर्पस यू हैव टू कम हियर ऑन टू एरोज पे आप डिफरेंट एक्सप्रेशन सिलेक्ट कर सकते हो। वेलोसिटी, प्रेशर आई विल सिलेक्ट एंड आई विल प्लॉट इट। सो यहाँ पर देखेंगे, सो हाउ मच इज द डायमीटर ऑफ दैट पाइप का डायमीटर कितना है, 0 to 0.41 इतना हाइट था उसका। सो at nearer to this pipe pressure is 0 and at the center you are getting what, maximum pressure of 0.2, बराबर है। सो ऐसा आपने डायग्राम देखा होगा जब आप सेकेंड ईयर में थे, तो शायद आपने ऐसा डायग्राम देखा होगा. This is what pressure distribution at nearer to or at inlet section. You can check at different section also. Okay. यदि आपको 3D में देखना है वो तो 3D में भी देख सकते हो आप. आपको प्रेशर डिस्ट्रीब्यूशन एट डिफरेंट पॉइंट सेलेक्ट करना है वो भी आप सेलेक्ट कर सकते हो. सो नाउ विल चेक इन 2D प्लेन प्रेशर डिस्ट्रीब्यूशन कैसे होता है. Again I will click here on two arrows, velocity and pressure. Okay, so here you can see what this is the pressure distribution. Okay, so here you can see minimum pressure is present at back side of this obstacle, but maximum pressure you will get for where? Maximum pressure you will get at on that obstacle पे आपको maximum pressure मिलेगा. You can find that also with the help of 1D plot group. Okay, समझ में है आपको? Are you getting? Okay, one more thing also you can do, you can solve this problem by using time dependent. In time dependent what will happen? So I will delete this stationary study. So I will take more 5 minutes. And we'll add the time dependent. In time dependent what will happen with respect to time, that pressure and velocity will change. So study I will take the time dependent, and here I will give time range. So जो यदि आपने पाइथन किया होगा, पाइथन में हम टाइम रेंज देते हैं, टाइम स्टेप प्रोवाइड करते हैं प्रॉब्लम. सो दैट आल्सो वी कैन प्रोवाइड हियर. द फैसिलिटी इज गिवन हियर. तो यहाँ पर आप प्रोवाइड कर सकते हो. देखो टाइम रेंज, this is the starting time, this is the step function, step value, and this will be the stop value. Okay, now next to that meshing we will keep same meshing normal and we will solve. So it will take 1 to 2 minutes for solving. So you can see the some difference in between the stationary study and the time dependent study. So what is changes in stationary study, the parameters are not varying with respect to time, but here in time dependent that parameter, which parameters? Laminar में क्या रहेगा? Pressure and velocity. So that pressure and velocity will vary with respect to time. Only 5 minutes are required, then we'll close this session. Naik sir, are you there?
Yes, sir. Yes, I am there.
So here you can see this is the conversion plot. Initially the error will be larger and after that that error will be reduced, and now that error is constant. तो एरर कांस्टेंट रहेगा तो आप क्या करते हो अपने न्यूमेरिकल मेथड्स में देखा होगा. सो यू आर कन्वर्जिंग योर प्रॉब्लम एंड आप प्रॉब्लम सॉल्व करना स्टॉप कर देते हो, वही आपका आंसर है ऐसा बोल देते हो. ठीक है. सो दैट स्टेप्स यू कैन सी हियर in log. You can see this is the numerical method steps. Here you can see the difference in between errors. I think those who have attended this session, at least they have to download this software and start to do practice. So it will be useful in a research field, और आपको यदि इंडस्ट्री में जाना है तो इंडस्ट्री में भी इसका, और पैरेलल टू दिस एनसिस में भी इसका एप्लीकेशन होगा. एनसिस में भी आप मतलब सेम ही सॉफ्टवेयर, बोथ सॉफ्टवेयर्स आर सेम सॉफ्टवेयर, बट डिफरेंट इज दैट व्हाट एक्यूरेसी, थोड़ा एक्यूरेसी में डिफरेंस है उतना है. This is the time dependent problem. Due to that reason it is taking a time. इसमें आपको एनिमेशन भी देखने को मिलेगा. रीजन बिहाइंड दिस इज व्हाट टाइम डिपेंड एनिमेशन के लिए आपको टाइम डिपेंडेंट पैरामीटर्स की जरूरत पड़ती है. Okay, so here you can see this is the solution of the time dependent study. So here also same pattern you can see. The velocity has been increased nearer to this obstacle area. Okay, this is the pressure distribution also you can see in the form of contours. Now next to that, one more thing we can see here, animation. I want to show you animation, how the air is flowing through the pipe. Okay, I want to pause this. Okay, here you can see the velocity, how the velocity is flowing. Actually, initially I have given the less time step, and after that, that flow of the fluid will get stable. So यहाँ पर देखेंगे तो I have provided the impact, and after that the flow of the fluid is getting stable here, because I have provided the less time step, more time step, मतलब उसका स्टेबिलिटी के लिए हमने ज़्यादा टाइम प्रोवाइड किया था. ठीक है. So this is the simulation of the laminar flow by using the time dependent. Okay. So now with this we will stop this session. So I request all of you to please download this software. I have told you how to download this software. If you have any query regarding the how to crack this software, I will help you. Okay. Thank you. Nice, sir.
Okay. Yes, sir. Yes, sir. Thank you very much, sir, for this very nice session. Now I request all the students, if you have any query, then you can ask. Yes, anyone? If you have any query regarding this, you can ask.
If you have any query, then also you can come to me and meet me. I will
Yes.
I will give you software, how to install this software. If you want to solve the more heat transfer problem, we'll sit together and we'll solve such problem also. Okay.
Okay. Yes. So I think there is no any query. So I request all the participants, please switch on your video so that we can take one screenshot. All students, please switch on your video. Mali sir, please also. Yes, all participants, please switch on your video fast. Okay, okay. Now turn on your videos. Turn off. Sorry. Yes, switch off your videos now. So now I give the vote of thanks. So as already this session is very nicely explained by Amol Mali sir. All the aspects of heat transfer has been covered in this particular session. After completion of this particular session, I hope all the participants might got the idea about how to install the COMSOL software and how to do the modeling and how to do the analysis of this particular heat transfer problems in this COMSOL software. Okay, so Mali sir also focused on all the three modes of heat transfer, that is conduction, convection, and radiation. I think radiation has not covered, but main that is conduction and convection part that is covered in this particular session, and all the examples related to that two modes have been has been covered. So I am very much thankful to our expert, that is Mali sir, for giving us his valuable time from his busy schedule. I am also thankful to our HOD sir and our Dean of Academics for supporting and giving the permission to conduct this particular session. Thank you very much, all the participants as well. I have shared one link in this particular chat. Also, I will share this link on the WhatsApp group, wherein you have to give your feedback, and also you have to attempt one quiz. In that, there are total 10 questions provided. So the passing criteria for that particular quiz is 40%. If you score the 40% marks, then you will get a certificate on your email ID directly. So you have to fill your full name, that is as you required on the certificate. Okay, and you have to provide the correct email ID for that. So thank you very much, Mali sir, for your valuable time and very nice session on this particular heat and mass transfer subject. Thank you very much. So now I conclude that this session is over. Thank you very much.
Thank you, sir.
Yes, thank you. Thank you.